Okay, so today I'm going to start a new unit on magnetism. So probably your experiences with magnetism have been that if you've held two magnets near each other, depending on the orientation of the way you're holding those magnets, it will determine whether those magnets are attracting to each other or repelling from each other. So magnets or things with magnetic properties can either repel or attract. And we know that this is similar to electrical properties of objects. Specifically, it's similar to the way electrostatic forces work. So I say that because it's important to realize that magnetism is associated with its own type of force. It is associated with a magnetic force. And those magnetic forces, as we previously said, can either be repulsive or they can be attractive. So what makes them repulsive and what makes them attractive? Well, we know that a bar magnet, many of you probably already know this, a bar magnet has two poles. It has a north pole and a south pole. Now, before we talk about what's repulsive and what's attractive, I just want to make a note that if we broke this bar magnet in half, right, break a bar magnet in half, we won't just have a North Pole magnet and a South Pole magnet. This is not what happens. So we won't end up with these monopole magnets. We won't end up with monopoles Instead, you will still end up with two bar magnets that each have a north and south pole, a north and south pole. So that polarity, as we're going to refer to it, is preserved. So polarity is preserved here. So it's important to note you'll never have a monopole magnet. It doesn't exist. Okay. So I want to talk about what is the cause then of this polarity. And the cause of polarity is something called electron spin. Okay, so what is the cause of this polarity? And as I said before, the cause of this polarity is electron spin. So we're going to talk about electron spin in two different ways. It can either be spin up or spin down. And this was shown in an experiment called the Stern-Gerlach experiment. So the Stern-Gerlach experiment basically proved that there are only two spin states. Spin up and spin down. And I'll show you how it did that. The way that I want you to think about these spin states before I talk about the experiment is you can think of up and down as being the difference between something rotating clockwise versus counterclockwise. Okay. So think of spin up and spin down as referring to an electron moving clockwise versus counterclockwise. Okay. So the way the Stern-Gerlach experiment worked was that basically there was a magnetic field created between these two plates. So a magnetic field was generated and silver atoms were pushed through this. So a beam of silver atoms was pushed through this magnetic field. Now, why would they choose silver? Well, silver, sorry, you can't see that. So a beam of silver atoms was pushed through this magnetic field. Okay, so why would they choose, so why silver? Well, silver only has one unpaired electron. I'll explain that in a second. So silver only has one unpaired electron. And it's a very stable atom. And is relatively stable. And what they found was that half of these silver atoms were deflected up and half were deflected down. So half of these silver atoms were deflected up and half were deflected down. Thus evidencing the existence of these two spin states. Okay.